You're welcome to day 32 of 50 days of tutelage. In today's class, I will be teaching you about temperature and thermometry. What is temperature? Temperature, simply put, is the measure of how hot or how cold a body is. So it is a determination of the degree of hotness or the degree of coldness of a body. So when you say a body is lukewarm, when you say a body is hot, and when you say a body is cold, what you are simply trying to estimate is the temperature of the body. Mind you, this does not interpret to the quantity of heat that the body possesses. Of course, there's a kind of relationship between them, but the two of them don't necessarily mean the other. For instance, because a body is hot does not mean it has higher energy than a body that is cold. Heat energy depends on so many other things, which I'm not going to be discussing majorly in this video, but I will make a proper clarification on them as well. So, temperature is the measure of how hot or how cold a body is. But a better definition is that temperature is the measure of the average kinetic energy, of a body or of the particles of a body. So if you have a body now, let's say this is a body, and then this body is made up of several particles, several internal particles like this. The average kinetic energy of this body is the measure of the average kinetic energy of these particles is actually what determines the temperature at that point. So the difference between temperature and heat, like I've said already, is that heat is a form of energy. And heat usually depends on mass, it depends on a certain property known as specific heat capacity, and it depends on the change in temperature. So, one thing about heat energy is that heat energy is always transferred from any two bodies that are not at the same temperature. So, when you have two bodies that they have varying temperature, then heat energy is always going to be transferred from one to the other. So, but however, if a body is at 10 degrees Celsius and another body is at 50 degrees Celsius, of course, this 50 degrees Celsius has a higher temperature than this body, but it doesn't necessarily mean that they have a higher amount of heat energy than this other body. Like I said, there are other factors that determines that. So take note of that. Higher temperature does not necessarily mean that it is having higher amount of energy. And I'm going to clarify this further as we continue. So we have temperature scale. Since temperature is a measurement, is a way we measure how hot or how cold a body is. Then we have scales of measurement. For temperature, we have three major scales of measurement. We have the Celsius scale. So we have the Celsius. We have the Celsius scale, and we have the Kelvin scale, and we have the Fahrenheit scale. This Fahrenheit, I'm always confused about the spelling. So we have the Fahrenheit scale as well. And each of these guys, they have their fixed points. They have their upper fixed point, they have their lower fixed point, and we have temperature that are intermediate between them. So for instance, the Celsius scale is such that we have the upper fixed point, and we have the lower fixed point. For the upper fixed point here, we have a temperature of 100 degrees Celsius, and lower is 0 degrees Celsius. For the Kelvin, the upper fixed point here is a temperature of 373 Kelvin, and the lower one is 273 Kelvin. For the Fahrenheit scale, we have a temperature of 212, and at the bottom here we have a temperature of 30 degrees Fahrenheit. So you need to be familiar with this scale as well. So in between them we have varying temperature, so anything between 0 to 100, 99, 80, 24, and all of that. So in between them we have this varying temperature and all of that. So I'm still going to be explaining this better as we continue with the class. So let's talk about thermometry now. What is thermometry? Thermometry is simply the everything that goes behind measurement of temperature. So if you use thermometer to measure temperature, how then do we construct a thermometer? What determines the things that we put in a thermometer that makes them work the way they do? So this is what thermometry is all about. And basically what we're going to be dealing with here is the um, physical they are the physical properties of substances. They are physical properties of substances. That is why we have different type of thermometers. We have the liquid in glass thermometer. We have the clinical thermometer, which is also a special type of liquid in glass thermometer. We have the thermocouple thermometer. We have the resistance thermometer, and we have the constant volume gas thermometer, and all of those things. So I'm going to explain some of them to you because they are very very important to understand. So, but for some of them, I'm just going to list them out, and you're going to like just check them out on your own. So let's start with the liquid in glass thermometer. So for the liquid, so I'm going to call that LIG, liquid in glass thermometer. So what is a liquid in glass thermometer? So the basic thing about this is that it makes use of liquid. And the property of liquid that it uses is the fact that the volume of liquid expands when you supply heat to them. So when there's a change in temperature, the volume of liquid, it increases, it expands. So if you have a liquid in a certain narrow tube now, and let's say the liquid is at a particular level, so the moment you introduce a change in temperature to it, the liquid can rise up in that place. And what happens is that we calibrate that narrow tube. So there's a proper measurement that has been done. The narrow tube is calibrated. So here you can say this is a temperature of 10 degrees Celsius, this is a temperature of 20, this is a temperature of 30. So as the liquid is rising, then you are able to tell what the particular temperature at that particular point is. So that is what liquid in glass thermometer, that is what it does. It uses the physical property, which is volume of liquid. So that is what liquid in glass thermometer is all about. Now we have the option of choosing between two liquids. Actually, we have the mercury and we have the alcohol. However, mercury is always the preferred choice. The reason is because it has a wider range of temperature, meaning that its temperature range, especially at the boiling point, it has a very high boiling point. And having high boiling point is very good because with high boiling point, it does not vaporize easily. So imagine you want to measure a temperature and the temperature is maybe something around 80 degrees Celsius. And imagine the boiling point of the substance, the liquid that you are using. Imagine the boiling point is, let's say, 50 degrees Celsius. So that implies that before you reach the temperature of 8 degrees Celsius, the liquid already vaporized from the tube and you will not be able to take any measurement. So, and for mercury actually has a very high temperature, high boiling point rather, something as high as 357 degrees Celsius. And the freezing point is around negative 39 degrees Celsius. So this is actually a very good room for us to take as much measurement as we want to take. So alcohol, on the other hand, this is has a boiling point of 78 degrees Celsius. So anytime you are measuring a temperature that is above 78 degrees Celsius, alcohol will not be very favorable. But alcohol is actually much better when you're measuring very, very low temperatures. So such that its own freezing point is negative 115 degrees Celsius. So with this, you can easily measure very cold. So in this case, mercury is still preferred overall because negative 39 degrees Celsius is still a very low temperature. So which makes mercury like a very, very good one. So mercury is winning at high temperature. Now, alcohol is winning at low temperature, but mercury is not bad either. It's just that alcohol goes to the extreme, extreme, extreme cold extent. So in terms of temperature range, mercury is the better guy. Another thing that mercury has over alcohol is that mercury is actually opaque. But alcohol blends with glass. Alcohol blends with glass. What does that imply? It implies that you can easily read what mercury is inside a glass because it is opaque. You can easily see it. But alcohol blends with glass. So you have to actually add a form of coloring to the alcohol before you can use it, before you can easily spot it. And that thing that you are adding to color it as well can also have effect on the temperature that you want to measure. So it actually makes alcohol not really, really like the best like that. So mercury, I've told you now, it has a very wide range of temperature. It's also a good conductor of heat. It does not wet glass because another thing that it happens is that alcohol wet glass. So if alcohol is wetting glass, one of the things that can happen is that in the bore of the thermometer, there can be uneven expansion. You can begin to have bubbles. you can begin to have bubbles formed, such that even though this thing is rising up to this level, there are some empty spaces there. But with mercury, because it does not wet glass, it just rises uniformly in the bore of the two. So, which is why, as a liquid in glass thermometer, mercury is mostly preferred. Now, let's go to the next one, clinical thermometer. Clinical thermometer. This is a special type of liquid in glass thermometer, actually. And this special type of liquid in glass thermometer is used mostly in the hospital. Of course, the temperature range is a little bit lower because you are measuring the temperature of human body. So you always have it between 35 degrees Celsius to 42 degrees Celsius. So where the temperature of a normal human body usually falls. Now, a special feature about this clinical thermometer is that this is, so I'm going to sketch it now. Don't mind my sketch. It's just going to look a little bit funny. Okay, so you have something of this nature. Um, just gonna have this right here. Okay, yeah. So this curly part is called a kink or a constriction. Is called a kink or a constriction. And what is the purpose of this is that it enables you to be able to read the temperature measurement. For instance, when you place this thing, like if you go to the hospital, this is most likely going to be placed under your armpit. And what happens is that there is a kind of expansion. And the thermometer is always made to be very sensitive such that it can detect any little change in temperature. So when it does that, this expands and it measures a certain temperature. Let's say it's measuring 25 degrees Celsius. Just an example. But you see, the moment you release this thing from your armpit or from anywhere that is being measured and you expose it to the atmosphere, because of the sensitivity of the thermometer, it quickly adjusts to the immediate temperature of the surrounding. So, which implies that it's no longer going to be 25 degrees Celsius. It can go as low as 0 degrees Celsius or let's say 5 degrees Celsius and all of those things. So, because you want to prevent that, the doctor will not be able to see the actual temperature that is being measured. So, this kink is actually like there to prevent the backflow of the expansion. So, it keeps this in place and you are able to see that, oh, the temperature measurement is actually 25 degrees Celsius. However, whenever it is going to be reused, this is why this thermometer is always going to be shaken before you use it again. So you have to shake it before you reuse it, and that is for the clinical thermometer. So we also have the sixes maximum and minimum thermometer, and we have the sixes maximum and minimum thermometer. We have the thermocouple. We have the thermocouple. So I'm not going to be going into too more details about those ones. We also have the resistance thermometer. We have the resistance thermometer. Now we have the constant volume gas thermometer. So we have the constant volume gas thermometer. Now, so or short form gas thermometer. And it works on the principle of pressure versus temperature. So this is actually using the physical property of pressure to measure the temperature. And it's actually the standard thermometer. It's also regarded to as the standard thermometer because it can be used to, so it is also regarded to as the standard thermometer. So it is used in the calibration of all these other type of thermometer because it is perfect. Because most of the gases that are used are ideal gases. Ideal gas behave perfectly under temperature and pressure and all of those things. So it is a very, 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 very good one. However, it is not commonly used like the liquid in glass thermometer based on some properties. It is slow, it has different defaults and all of those things. So these are the different types of thermometers, and then I believe I've been able to do proper justice to that. Now, the next thing we want to talk about is the sensitivity and accuracy of a thermometer. A thermometer has to be very, very sensitive. I've already mentioned that earlier, so that it can detect very small change in temperature in the surrounding. And one of the things that establish this is that there's a long capillary tube which is narrow. A long capillary tube which is narrow is actually very, very, very important because with this, if it is long and it is narrow, any little change can easily be detected. That's number one thing about a thermometer, that is going to be very sensitive. It has a long capillary tube, and it is what? And it is narrow. Another thing about the bulb is that about the thermometer is that for the bulb of a thermometer. So from this sketch I made earlier, this is kind of like the bulb. This bulb must be made with materials that easily detect temperature. So that's another thing as well that you need to take note when you are constructing a thermometer. Accuracy as well. The reading of a thermometer must be close to the temperature value. That is, when you are comparing it with the constant volume gas thermometer, a thermometer must be able to have at least a close. So if this one will determine 24 degrees Celsius, then this one should be able to determine something like 24.1 degrees Celsius, or let's say at most 24.5 degrees Celsius. So accuracy in comparison with the gas thermometer, any other type of thermometer must have a reading that is close to this as well. So that's another thing about this as well. So you can increase the sensitivity of a thermometer by having a narrow tube and making it long. You can make the bulb, you can make it very, very sensitive so that you use materials that easily respond to temperature change. And you can even make it wider as well. If it is wider, it also helps in what? Um, in making the thermometer very sensitive. So these are the things that you must take note. And so before I go to talk about boiling point and boiling itself, I want to talk about temperature calculation. So I've given you this temperature scale now. You can easily convert from one temperature scale to the other. All you just have to do is, so for instance, if I want to convert from, let's say, Celsius to Fahrenheit, so all I have to do is I can say this side is for Celsius, this side is for Fahrenheit. So the upper fixed point here is 100 degrees Celsius, and the lower fixed point here is 0 degrees Celsius. The upper fixed point here is 212 degrees Fahrenheit, and the lower fixed point here is 32 degrees Fahrenheit. So all you have to do is to just do this, form a fraction, remove the lower fixed point from the two guys above. What I mean by that is 100 minus 0 divided by C minus 0, and equate it to the right hand side. Do the same thing as well. That will be 212 minus 32 divided by F minus 32. So when you do this, you'll be able to do proper conversion. So in this place, you have 100 minus 0 is 100, C minus 0 is C, 212 minus 32 is 180, and you have F minus 32 here. So that implies that if you this can actually divide each other, then this can also divide. 2 can divide here, so you have a 5 here, and you have 9 in this place. So therefore, if you kind of cross multiply, you have that 9C equals 5 multiplied by F minus 32. And with this, you can divide both sides. So C is going to be 5 over 9 multiplied by F minus 32. So what does that imply? If you have a certain temperature in Fahrenheit and you want to convert it to Celsius, you can just substitute that Fahrenheit temperature into this expression and you'll get your temperature in degrees Celsius. So that's basically how you can do. So you can do this for other one as well. And then you can also use it for some other measurement. For instance, if you're comparing the temperature with resistance, so some resistance will correspond to the upper fixed point, some will correspond to the lower fixed point, and all of that. So you can easily use this table for your calculation. Now let's talk about boiling and boiling point. So what is boiling? Boiling is simply the process whereby liquid changes rapidly into vapor. So if you have a liquid in a container now, so you have a liquid in this container, boiling is taking place when this liquid is changing to vapor. However, this whole changing to vapor is not happening at the surface only. This must be happening throughout the entire liquid. Then when that is happening, you say boiling is taking place. Now, the process of boiling will only happen based on this condition. The condition is that there is a kind of internal pressure here, and this internal pressure in the liquid gives rise to what we call saturated vapor pressure. But there's also what we call external pressure, so the pressure that surrounds it, that is outside the vessel you are using to boil the water. This is called the external pressure. external pressure. If boiling will take place, what usually happens is that this must match each other. The SVP must be equal to the external pressure. When this happens, that is exactly when boiling is said to be happening. So what does that now imply? It implies that if something should happen to the external pressure, for instance, if the external pressure is increased, that implies that this SVP has to also go up. So let's say there is a normal external pressure, then the SVP matches the normal external pressure. The SVP is also changing based on temperature as well. So increase in temperature causes it to what? Causes it to increase, and then decrease in temperature causes the SVP to reduce as well. So here's what happened. There's a particular temperature which this must get to for the SVP to be reached and equal to the normal external pressure. That temperature is known as the boiling point of the liquid. So the temperature at which the saturated vapor pressure in a liquid equals the normal external pressure or the normal atmospheric pressure at sea level, when that temperature is known as the normal boiling point of the liquid. However, because this external pressure can be changed, that is, it can be increased or it can be lowered. When it is increased, that means that SVP must also increase, because for boiling to happen, they must be equal. So if SVP increases, that implies that the temperature at which that SVP occur will also increase. So therefore, what you have done there is that you have raised the boiling point. And because you have raised the boiling point, that means that that substance will not boil until it has reached a temperature that is higher than its original boiling point. For example, water, original boiling point of water is 100 degrees Celsius. If you raise the external pressure, what is going to happen is that the SVP is going to increase, and so therefore the boiling point will raise above 100 degrees Celsius. But the same thing, if you reduce the external pressure, then the SVP will also be reduced. That means that you can actually get to the SVP faster self, because now you don't need too much to be done to match the external pressure. So therefore, the temperature will be lower as well. So what if you now make this external pressure to vanish totally? If you make it to vanish totally, that is in something like a vacuum, such that there's no external pressure, then that implies that this SVP2 will be equal to 0. And you need a minimum temperature of, let's say, 0 degrees Celsius for that to take place. And this also is boiling. So boiling is also taking place at this point as well, even though the temperature is 0 degrees Celsius. So boiling point can vary. It can increase and it can decrease. The only thing is just that when you are talking about normal boiling point, you are dealing with the atmospheric pressure at sea level, the standard atmospheric pressure at sea level. But when you change anything about this, it causes the boiling point to go up or to come down. Now, this increase in boiling point and decrease in boiling point, which one favors cooking? You see, cooking requires energy. And then for the higher the temperature, the higher the energy. I had stated earlier that heat energy depends on three major things: mass, specific heat capacity, and change in temperature. So therefore, if there is increase in temperature, there's going to be cooking. More cooking, cooking will be done effectively. And this is the effect of a pressure cooker. It increases the pressure. So if it increases the pressure, it causes SVP to go up, making the temperature to go higher as well. So therefore, you have a higher change in temperature and more energy is applied. So it favors cooking, which makes cooking to be done faster. So even though boiling point has been raised, but it now supplies more energy. So therefore, cooking is favored. But when boiling point is lowered, that is, imagine you have a boiling point of 0 degrees Celsius. That implies that lesser energy, and therefore cooking is going to take more time to be done. And that is exactly what boiling point and the variation is all about. So this should make sense to you now. And this is basically the summary on temperature and thermometry. I believe you've learned a lot in this class. So if you've done that, make sure you like, subscribe to the channel. I'll see you in the next one.